For centuries, we've been taught that the solar system is calm, orderly, and predictable. A perfect cosmic machine, ticking quietly through time. Planets follow precise paths. Gravity holds everything together. At least, that's how it appears. But in science, appearances can be misleading. Especially when time is measured not in years, but in millions. When scientists study the solar system over long periods, a different picture begins to emerge, one that is far less stable than we once believed. The truth is unsettling. The solar system is not a perfectly balanced clockwork. It is a dynamic system, constantly changing. Small shifts in gravity, almost invisible today, can grow into significant changes over time. And once they begin, they cannot simply be reversed. In scientific terms, this behavior has a name. It is called chaos. Chaos does not mean randomness. It means sensitivity, where tiny variations can lead to unpredictable outcomes. Even the most precise calculations cannot fully predict how the solar system will behave millions of years from now, because the system itself is inherently unstable. This instability is not new. It has shaped the solar system from its earliest moments. Planets have shifted positions. Orbits have changed. Worlds have collided and disappeared. What we see today is not a final arrangement. It is a temporary balance. One that exists only within a narrow window of time. And this raises an uncomfortable question. If the solar system is unstable, but how long can this balance last? The answer is not simple. But it begins with understanding how this system was formed. To understand why the solar system is unstable today, we must first look back to a time when it was far more violent than it is now. The solar system did not begin in balance. It emerged from chaos, violence, and constant motion. In its earliest days, the sun was surrounded by a vast disk of gas and dust. Nothing had a fixed position. Within this disk, countless fragments collided, merged and shattered. Planets were not born gently. Within this disk, countless fragments collided, merged and shattered. Planets were not born gently. What remained continued to move. Even massive planets did not stay where they formed. Scientists now know that planets migrate. They drift inward or outward as gravity reshapes the system. Jupiter, the largest planet, played a crucial role. Its movement altered the fate of every other world. As Jupiter shifted, it scattered smaller bodies across the solar system. Some were thrown into deep space. Others were sent inward, toward the inner planets, including the region that would one day become Earth. This period was not brief. It lasted millions of years. During this time, the architecture of the solar system was rewritten. Order slowly emerged from destruction. The planets we see today are survivors. They occupy positions shaped by countless past interactions. But survival did not mean stability. It meant temporary balance. Even after the early chaos faded, motion never stopped. The system continued to evolve. What appears calm today is the result of long-term settling, not permanent equilibrium. The solar system learned to appear stable, but it never truly became fixed. Its history is written into every orbit, every tilt, every distance between planets. This ancient instability explains something important: why perfect predictability is impossible. Because the system was shaped by chaos, it still carries the fingerprints of chaos today. To understand the future of the solar system, we must remember that its past was never calm. Today, the solar system appears calm. But beneath that calm surface, motion never stops. Every planet continues to move. Every orbit continues to shift, however slightly. These changes are not dramatic on human timescales. They unfold slowly across millions of years. Even tiny gravitational interactions can accumulate. Over time, small forces reshape entire trajectories. This is why long-term prediction becomes difficult. Not because science lacks precision, but because the system is sensitive. In chaotic systems, small uncertainties grow. A minute difference today can lead to a vastly different outcome tomorrow. This sensitivity limits how far into the future scientists can see. Beyond certain points, certainty fades. Computer simulations reveal countless possible futures. Some stable, some not. Most of these scenarios unfold far beyond human lifetimes. But they are real possibilities. Planetary orbits can stretch, tilt, or shift. Not suddenly, but inevitably. Asteroids and comets add further complexity. Their paths are influenced by every major planet. A single close encounter can alter an object's course permanently, sending it inward or ejecting it forever. Jupiter continues to play a central role. Its gravity shapes the movement of smaller bodies throughout the system. In many ways, Jupiter acts as both shield and threat, deflecting some objects while redirecting others. Earth exists within this delicate balance, protected, but never completely isolated. Stability, in this context, does not mean permanence. It means temporary resistance to change. The solar system is stable only within limits. And those limits are defined by motion. Beyond them, prediction gives way to probability. And certainty becomes impossible. This does not signal danger tomorrow. It reflects the nature of complex systems. To understand the solar system, we must accept uncertainty as part of its design. Earth exists within a system shaped by motion. Not isolated, not protected by permanence. Its orbit is stable for now. But stability in cosmic terms is always conditional. This does not mean catastrophe is imminent. It means change is always possible. The forces that shaped the solar system in the past are the same forces acting today. Gravity never rests. It never stops adjusting the balance. Over time, even the smallest influences can matter. A passing object, a subtle shift. Science does not view this as danger. It views it as reality. By understanding instability, we better understand why the solar system looks the way it does. The present arrangement is not a design. It is an outcome. An outcome shaped by survival, interaction, and chance. This perspective changes how we see stability itself. Not as a guarantee, but as a phase. A phase that exists within narrow boundaries. Beyond those boundaries, motion takes over. The solar system does not promise permanence. It offers balance for a time. And within that balance, life emerged. Not because the system is perfect, but because it is resilient. Understanding this fragility does not diminish our place. It deepens it. We are part of a system still in motion, still evolving. The solar system is not stable. And it never was. but within its shifting balance, it has allowed us to exist. And to understand it,